The universe is an immense, almost unfathomable expanse that stretches beyond the boundaries of our comprehension. It's a limitless realm filled with countless stars, each one a luminous beacon in the vast darkness of space. Every star is a sun, often accompanied by its own orbiting planets, creating complex systems that move in a cosmic dance. As we gaze at the night sky, we are filled with wonder, pondering the mysteries that lie beyond our reach. Are we alone in this vast cosmic ocean? Is there another form of life looking back at us from a distant star? Could there be life out there on a distant world waiting to be discovered? This question has intrigued humanity for centuries, driving us to explore and understand the universe. Today we possess the tools to seek answers, tools that our ancestors could only dream of. We've constructed powerful telescopes, both on Earth and in space, capable of peering into the farthest reaches of the cosmos. These instruments can observe across incredible distances, unveiling the secrets of distant galaxies. They can analyze the light from distant stars, breaking it down into its component colors to reveal hidden details. And they can even detect faint traces of planets orbiting those stars using techniques like the transit method. The search for extraterrestrial life is no longer confined to science fiction. It's a scientific pursuit grounded in rigorous research. It's a scientific endeavor driven by data and fueled by our insatiable curiosity. As we analyze the vast amounts of information collected, we are explorers navigating the cosmic ocean, searching for other shores, driven by the hope that we are not alone in this vast universe. Our quest for life beyond Earth begins close to home. We turn our attention to the stars in our own cosmic neighborhood. One star in particular has captured our imagination, Proxima Centauri. It's a red dwarf star, smaller and cooler than our own sun. Proxima Centauri is our closest stellar neighbor, a mere 4.24 light-years away. That might seem like an immense distance. And it is, at least with our current technology, but on the scale of the cosmos, it's a stone's throw. In 2016, astronomers made an exciting discovery. Orbiting Proxima Centauri, they found a planet. They named it Proxima B. This exoplanet, as planets around other stars are called, is special. It orbits within Proxima Centauri's habitable zone. The habitable zone is the region around a star where conditions are just right for liquid water to exist on the surface of a planet. Liquid water is essential for life as we know it. So finding a planet in the habitable zone is a major step in the search for extraterrestrial life. Proxima B's discovery sent ripples of excitement through the scientific community. Could this nearby world harbor life? The possibility was too tantalizing to ignore. Proxima B is thought to be a rocky planet, similar in size and mass to Earth. But that's where the similarities end. Proxima B orbits much closer to its star than Earth does to the Sun. This close proximity has profound implications for the conditions on Proxima B's surface. Proxima B is tidally locked to its star, Proxima Centauri, which is the closest known star to our solar system. This means that one side of the planet always faces the star, bathed in perpetual daylight, creating a stark contrast with the other side. The other side faces away, shrouded in eternal darkness, never seeing the light of its star. This tidal locking creates extreme temperature differences between the two hemispheres, with one side scorching hot and the other frigidly cold. The day side is likely scorching hot, with temperatures soaring to unbearable levels, while the night side is likely frigidly cold, possibly reaching sub-zero temperatures. These extreme conditions make it unlikely that life as we know it could exist on the surface of Proxima B, as the environment is too harsh for most known life forms. However, there is a glimmer of hope for potential habitability. Between the scorching day side and the freezing night side lies a region called the Terminator, a narrow band where the two extremes meet. This is the twilight zone where day meets night in a perpetual sunset, creating a unique environment that is neither too hot nor too cold. The Terminator might offer a more temperate environment with conditions that could potentially support life. Could life exist in this narrow band of possibility? Scientists are intrigued by this question and are eager to explore further. The promise of Proxima B lies in this delicate balance where the potential for life might just be waiting to be discovered. The close proximity of Proxima B to its star creates other challenges for life. This exoplanet orbits within the habitable zone where conditions might be right for liquid water. However, being so close to a red dwarf star brings its own set of difficulties. Red dwarf stars like Proxima Centauri are known for their powerful flares. These flares are not just minor disturbances, they can be massive, releasing tremendous amounts of energy. These are sudden bursts of energy that can be incredibly destructive. They can outshine the star itself for brief moments, sending waves of radiation across the system. Proxima B is bombarded by these flares, which would bathe the planet in intense radiation. This constant exposure to high-energy particles poses a significant threat to any potential life forms. This radiation could strip away atmospheres and boil away any liquid water on the surface. Without a protective atmosphere, the surface of Proxima B would be exposed to the full brunt of these stellar flares. The radiation environment on Proxima B is harsh, but life is resilient. Despite these challenges, the possibility of life cannot be entirely ruled out. We've found organisms on Earth that can survive in incredibly extreme environments. These extremophiles have adapted to conditions that would be lethal to most other forms of life. Extremophiles, as they're called, thrive in boiling hot springs, where temperatures can exceed the boiling point of water. In the depths of the ocean, where they endure crushing pressures and complete darkness. And even in the frozen wastelands of Antarctica, where temperatures plummet far below freezing. These organisms teach us that life can find a way, even in the most unlikely of places. The resilience of life on Earth gives us hope that, despite the harsh conditions, Proxima B might harbor some form of life adapted to its unique environment. Section 6. The Dance of Light and Darkness. The tidal locking of Proxima B creates a unique challenge for life. The perpetual dayside and nightside would have vastly different environments. The dayside would receive constant sunlight, while the nightside would be shrouded in darkness. The temperature difference between the two sides would create extreme winds. These winds would circle the planet at high speeds. The atmosphere of Proxima B, if it has one, would play a crucial role in distributing heat around the planet. If the atmosphere is thick enough, it could circulate heat from the day side to the night side. This could moderate temperatures and create a more habitable environment. However, if the atmosphere is too thin, the temperature extremes would be too great for life to survive. Section 7. Finding life in the twilight. The twilight zone, the region between the day side and night side, offers the most promising conditions for life on Proxima B. Here, temperatures would be more moderate, and there would be some protection from the star's intense radiation. If liquid water exists on the surface of Proxima B, it would likely be found in this region. The twilight zone would be a strange and wonderful place. The sun would hang low on the horizon, casting long shadows. The sky would be a perpetual twilight with the stars shining brightly overhead. If life exists on Proxima B, it would have to adapt to these unique conditions. Section 8. Life finds a way. Life on Earth has shown an incredible ability to adapt to extreme environments. We've found organisms living in boiling hot springs, in the depths of the ocean, and even in the frozen wastelands of Antarctica. These extremophiles thrive in conditions that would be lethal to most other forms of life. Could similar life forms exist on Proxima B? It's certainly possible. Life on Proxima B, if it exists, would likely be very different from life as we know it. It would have to adapt to the planet's unique conditions, such as the intense radiation, the extreme temperatures, and the perpetual twilight. But as we've seen on Earth, life finds a way. Section 9. A universe of possibilities. The discovery of Proxima B is a powerful reminder that we are not alone in the universe. It's a spark of hope in our search for extraterrestrial life. Proxima B is a tantalizing target for future observations. As our technology advances, we'll be able to study this nearby world in greater detail. We'll look for signs of an atmosphere, search for evidence of liquid water, and try to determine if Proxima B could indeed support life. The universe is full of possibilities, and Proxima B is just the beginning of our journey to explore them.